Hello everyone, welcome back to this Renault Master van conversion series, and in this episode we are going to be doing the plumbing. Electrics. Laid out in front of me, as you can see, is all the electrics that's going to go in this van conversion. So I'm just basically going to quickly run you through what I'm going to be putting in, and then we can cut to the installation. So I've already kind of pre-made a board here which will house most of the things like the bus bars, the fuses, the kill switch and the main fuse box, and that will basically be going kind of down here and hiding all the batteries and the chargers. So essentially, once it's all complete, all you will see is this. So running this entire van conversion, we've got 200 amp hour rely-on lithium batteries. So this gives 200 amp hours at 12 volts, which should be plenty enough power to run everything that we plan to put in the van. Then we've got a Renogy 40 amp DC to DC charger that will charge the battery when the van is running. So when the alternator is on, it will charge these batteries up. We've got a 2000 watt Renogy inverter, so this is a pure sine inverter, and this will basically allow you to run AC power from the DC batteries in the van. So this will run the induction cooktop and the AC power for the hot water and anything else AC that you want to run up to 2000 watts. Then we've got a 40 amp Fogstar AC charger, so this will allow us to charge the batteries from essentially regular household power. And we do also have a Campervan hookup point, so those two will sort of be connected so that when you're on hookup you can charge the main batteries as well. We've got a Victron MPPT, so that will connect the solar panel that's already installed on the roof to the batteries to charge up the batteries. And then because we've got lithium batteries and we need to track everything, all the power coming in and out, so we know what percentage these batteries are on, we've got a Renogy battery monitor as well, so that will connect to this shunt here. So all the circuits in the van will connect to the shunt here, and that basically means we can track everything coming in and out, and we'll know what percentage battery we're on. So yeah, I will be wiring all this up. So that's the reason we haven't built this part of the couch yet, because I now need to sit here and wire all this up. And the idea is to have all of this stuff mounted under the bed couch area. So if I remove this, the idea that we have these batteries, no,
I think they got the idea.
There we go. So the batteries are going to live under there, the inverter is actually going to live somewhere about there. These chargers are going to be mounted to the back wall, back over there. MPPT off to the side because that's where the solar power cables are. The AC charger above the batteries. And then essentially the front plate comes back on, and if I've got everything positioned correctly, we'll kind of block it off, make it look nice. Everything's contained behind. You'll see all your fuses for everything here. So this will be the fuse box fuse, the AC charger fuse, the DC charger fuse, the MPPT fuse. This big fuse up here is for the inverter. Then you've got a main kill switch to cut all power to the van. Then that will go into the batteries through that hole. All the negatives will come down onto the negative bus bar down here, connecting into the shunt so we can track everything, and then a big cable from the shunt to the battery. And yeah, so this is basically where you do the maintenance for 90% of the things that you need to do, and then if anything does go wrong you just remove this panel and fix whatever needs fixing behind. But in theory, once it's down there, you shouldn't need to touch it. So step one is to connect our two batteries together. So because we've got two separate batteries and we want to keep them at 12 volt, we basically need to connect the positive to the positive, so red to red, and the negative to negative, so black to black. And basically what that means is instead of having 100 amp hours and 100 amp hours, which is 200. We combine them together, so essentially it's just one 200 amp hour battery. And that way that we can just pull everything from one positive, and then it goes all back into the other battery's negative, and it treats it as one battery. And we don't want a 24 volt system, so we need to connect positive to positive, negative to negative. I will say before starting this, both of these batteries had been fully charged by our AC charger, so they are full charge essentially and the same voltage. That way connecting them together isn't going to cause a huge potential difference, and all the energy in one battery is going to suddenly rush to the other battery through the cable, because they're both basically the same amount of power in each one. There we go. That's positive to positive, negative to negative. The reason I've orientated it like this is because I want the main positive and the main negative to be close to the board, so the cable runs can be as short as they can be. Otherwise I have to stretch cable all the way around, which I don't really want to do. Step 2. AC charger has been mounted to wall. Step 3. Mount DC charger to the wall. Now what I've done, because the DC charger has to be connected to the starter battery of the van, I've ran our 16mm cable, black and red, positive and negative, round under this black thing here. And you can see that down here they pop themselves out. And in case you didn't know, the starter battery on these Renault Masters is on the passenger side of the van down here. So that cable comes out, runs down, put a grommet in there, and it will run down red to positive, black to negative. But I'll connect it on the other side first. But that's where that one all connects to. Before installing the MPPT, there is something very important that I actually want to show quite a lot of people, because the first time around it took us forever to figure it out, and I've had a load of people ask us the same thing when they can't get these things to work or charge properly. So in the main instructions that come with it, it doesn't actually state it. You have to go to their actual PDF, and what I'm going to be talking about is this thing down here, this rotary switch. Now it's very difficult for me to show you, but you see there's a tiny little arrow and it's currently set on level 2 or setting 2. Now if you look in the main PDF about this rotary switch, you'll see that level 2 is for gel Victron deep discharge and AGM Victron deep discharge batteries. Basically gives you a float voltage absorption voltage for each type of batteries that you could have. Now since most people installing these have lithium batteries, you actually want to put it on level 7. Get a tiny flathead screwdriver and just turn it. There we go. And you'll see now that little arrow is pointing to level 7 or setting 7. And now we can actually mount this on the wall. There we go. Right. Main positive, main negative are wired up. So I just I'll figure out how to screw that in entirely later, but I'll make it neat. Right, so we've got power to our battery monitor, implying that I've done the wiring correctly. So apparently I just need to set this up and then we can wire in a test subject. Capacity 200 amp hours and full voltage capacity. So for these batteries that was 14.6. Zero voltage, zero capacity voltage. Well, 0 volts. Power off is the shutdown voltage. So since these are lithium batteries, we don't actually ever want to drain them like all the way to 0. So normally turn off voltage is around between 10.5 and 11 volts. So I'm going to set this to 11 volts. Actually, I'll set it to 10.8. 10.8. So low capacity alarms. So normally we set it to 20% of the battery capacity. So when it reaches 40 amp hours, we can have it beep at us to tell us that we're on low battery and we need to charge it up. There we go. So the battery is now displaying as 100%, 200 amp hours, which is exactly what we have in the battery. Just had to reset it by pressing and holding the up arrow to say that the battery is full. So now I can turn the kill switch on. The solar panels are still covered, but the battery's full, so nothing should happen. Are we ready?
Mm-hmm. Dun, 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 dun.
Well, that was uneventful.
Well, you want it to be uneventful. What do you want? Fire?
There we go. So the MPPT is showing up on Bluetooth. It's showing as 0 watts, probably because the battery's full and the solar panel's still covered in cardboard. But there we go.
Right, now, make it work and show the numbers change. A wild Sam's going crazy with the wiring.
It's amazing how much wire goes into a van. I'm nearly done, alright? I've just got these 3 and the heater and the bubble tank, which I don't have the wire for, which comes tomorrow to do.
Nearly done, eh?
Nearly done.
Sounded like a long list.
It's a very long list. Right, just got these 3. But yeah, look, we've got everything in. I've got my notes on what is what.
Mm-hmm.
It's all fine. There we are. The electrics are done. By done, I mean there's cables running everywhere, but the main board is done. So yeah, what I've done is I've run cables from the fuse box down here and from the bus bars here and here, basically everywhere in the van that they need to go, labelled each end so we know what's going there. But because most of the furniture hasn't got its final boards yet, we can't put on things like the plug, we can't connect it to the heater and so on. So what they are is things like this. So here we are, we've got kitchen light, main light, got wires down there for the fridge, wires running up, that's in the bathroom there. The max fan is connected, but all this stuff runs in a giant cable highway under the bed there into the fuse box. And then all the big things like the MPPT for the solar, that's connected and working. The AC charger there needs to be connected to a fused plug and socket, which I'll do at a different time. And then we've got our DC charger there, which charges the battery when we're driving, which I have installed a very factory looking on off switch here. So when it's on and when the engine's on, it will turn the DC charger off and then you can switch it off. And from what we learned, it's really good having it on an actual switch, because if you're in traffic, let's say stop start traffic, and you keep turning the engine on and off, you don't want to drain your starter battery through your DC charger. So having an always permanent override switch is essential. But yeah, that's all the electrics done. Batteries are on 100%. Now, what are we doing next? Heating? Plumbing?
I don't.
One of those. We don't know. I declare the power on.